Hello, welcome to this lesson on solving base E exponential equations algebraically. We're going to go ahead and look at some equations with base E and solve them algebraically. For prior knowledge, I would like you guys to go ahead, pause the video, and try to solve this exponential property of equality. Go for it. All right, here's the solution. 625, that is 5 to the power of 4. So if you make 625 5 to the power of 4, in order to make this base 5, you have to use the negative exponent property. So you're just going to apply a negative to that 4. And then if the bases are the same, the exponents have to be the same. So we get x is equal to negative 4. Now, remember, the exponential property of equality, it can only be used when we're solving equations that have the same base. They have to have the same base. Now, that doesn't always work. So sometimes we'll use the logarithmic property of equality, which we just learned in the last lesson. Some other properties of logs that just are worth noting, we may or may not use them in this lesson, is that if I have a logarithm with the same base of a value, that answer is always going to be 1. And here's an example of it, which we will definitely use in this lesson. The natural log of e. Natural log is log base e. So these simplify, or you can kind of think about it as canceling out, that this is equal to 1. I would put a star by this property. We will definitely use this in this lesson. So the natural log of e is 1. Other properties worth noting for logarithms, the log of any base. It doesn't matter what the base is. The log of 1 is 0. Log of 1 is 0. And then again, if I have log base b of b, right, aren't these inverses? They will cancel out, and my answer is just going to be m. So if I have a power here, the answer is going to be m. Okay. So let's go ahead and look at some steps in order to evaluate a logarithm. Oh, sorry, that was the wrong slide. Here is the correct steps. So this should be what you have in your notes. So here are the steps in order to solve an exponential equation using the property of equality. Step 1, we'll write the equation with the single term. Step 2, take the natural log. Step 3, use the power property of logarithms. Step 4, solve the equation using algebra. And then step 5, state the solution. All right, so here is our first example. We have 12 is equal to e to the x plus 2. I'm going to go ahead and I'm going to solve. I'm going to subtract 2 on each side because I want a single term on each side. So we get 10 is equal to e to the power of x. Step 2, I'm going to take the natural log of each side, right? And this is ln. So the natural log of this side and the natural log of this side gives us the natural log of 10 is equal to the natural log of e to the power of x. Step number 3, I am going to go ahead and use the power property now. So that x up here is going to come down in the front. And I get the natural log of 10 is equal to x times the natural log of e. Here's where we're going to use that new property that we learned today. The natural log of e, this goes to 1. So this is just x times 1. So our answer is x on the right side, which gives us our answer. X is equal to the natural log of 10. Here's example number 2. We have 10 is equal to 5 times e to the power of 4x. I'm going to go ahead and I am going to first make these with one term on each side. So single term on each side. I'll get rid of the coefficient of 5. I just want my power expression here, e to the power of 4x. So I'm going to divide by 5 on both sides. We get 2 is equal to e to the power of 4x. Okay, now that I've done a single term on each side, I'm going to go ahead and I'm going to take the natural log of each side. So I get the natural log of 2 is equal to the natural log of e to the power of 4x. Step 3, I'm going to use the power property. So now my power comes down in front and multiplies. So the natural log of 2 is equal to 4x times the natural log of e. And then step 4, I'm going to go ahead and solve. So the natural log of e here, again, remember this is just 1. So that essentially kind of just disappears. I have the natural log, or it gets absorbed into the 4x. Natural log of 2 is equal to 4x. Okay, and to solve for x, I'm just going to divide by 4. Divide by 4. So x is equal to the natural log of 2 divided by 4. Something to be aware of, just watch this, don't write this down. This is not the natural log of 2 over 4, which is the natural log of 1/2. So just be aware, do not make that error. If you divide a logarithm, it does not move into the argument, into the parentheses, okay? So just kind of be aware of that. All right. All right, here is a practice problem. Pause the video and try this example. All right, here are the solutions. You had to make it a single term, so we isolated our power expression, dividing by 6, then used the natural log on each side to give us negative 3x natural log of e. Natural log of e is just 1, so it essentially gets absorbed into the negative 3x. And after isolating x by dividing by negative 3, this is our answer. If you left it as 15 over 6, I'm completely okay with 15 over 6. If you reduce 15 over 6 to be 5 over 2, that's also good. Here is the next example. So please go ahead and write this example down. Right away, I want to draw your attention to the exponent. If you see that the exponent has a binomial, there's 2 terms, put parentheses around it. I want to kind of protect that binomial. And so what I'm going to do again is step number 1. I'm going to write it as a single term, or I'm going to isolate the power expression. So I want to get rid of that 3. Get rid of the coefficient of 3. So I have 8 is equal to e to the power of x plus 1. I just want the base and the exponent. Just want the base and the exponent. Okay, step number 2, after I have a single term, I'm going to take the natural log of each side. So natural log of 8, natural log of e to the power of x plus 1. And I get the natural log of 8 is equal to the natural log of e to the power of x plus 1. And then step 3, I'm going to use my power property. If you kind of do step 2 and 3 at the same time, that's fine. So x plus 1 comes out in front. So I have natural log of 8 is equal to x plus 1. I'm going to leave the x plus 1 in parentheses. Natural log of e. What happens to natural log of e? That's 1. That's 1. So essentially gets absorbed into the x plus 1, into the exponent. And so I have natural log of 8 is equal to x plus 1. And I want to solve for x. So I'll undo addition by 1. And I'm going to subtract 1. Be careful. This negative 1 does not affect the argument at all. So natural log of 8 minus 1 is equal to x. And there's our answer. Okay. It does not become natural log of 7. It does not. So that was step 4, solve. And then obviously I stated the solution, step 5, okay? All right, here is a practice problem. Please pause the video and try this example. All right, here is the solution to this example. We go ahead, divide by 4 on each side. 64 divided by 4 gives us 16. Don't confuse this with base 4. Maybe if you saw this, you're like, hey, this is base 4, and I know 64 is 4 to the power of 3. Well, the base of this exponent is e. It's not 4. 4 is just a coefficient. So anyway, we go ahead and take a logarithm of each side, and we get x minus 2 is equal to the natural log of 16. Add 2 to both sides, and we get x is equal to the natural log of 16 plus 2. Put parentheses around this, and hopefully you notice in my examples I put parentheses around the argument of the 16. You cannot add the 2. If you have natural log of 18, that is not correct. Okay, it's just natural log of 16 plus 2 on the outside. All right. Okay, here is the next practice one. I think this is the last practice problem. Go ahead, try this, and I'll show you the answer here in a second. All right, here is the solution. This example was tricky just because we had 2 steps in the beginning in order to isolate our power expression. Step number 1, you need to go ahead and subtract 5 on each side. And then step 2, we divide. Kind of like going in that reverse order of operations method of solving, right? Undo, addition, subtraction, then division. So e to the power of x minus 1, they have 37.5 here. That's good if you divide it and you get it in the decimal form, but fractions are fine too if you have 75 over 2. Take a natural log of each side, and so we get x minus 1 is equal to the natural log of 37.5. Add 1, and we get our answer. All right. Here is the closure question. A student solved the equation e to the power of 4x minus 6 equals 10 as shown. What is the student's mistake? And then go ahead and correct the student's mistake. All right, here are the solutions for this example. What the student forgot to do is they took the common log base 10 of both sides. They did not take the natural log. So ln. The natural log of e is 1. The common log of e is not 1. I guess there's nothing wrong up until this step here. But since we have base e, we're definitely going to want to use the natural log. Okay, that's going to do it for this video. Hopefully you learned how to solve exponential equations with base e. I'll catch you in the next video. Peace.